Hello there! For this tutorial we are going to be creating this Flappy Bird game. It is almost an exact replica of the original, I just made some slight updates. And we are going to be doing the entire thing in Python with the pygame module, which is ultimately quite a simple thing, and the entire project takes less than 200 lines of code. And I am going to go through these specific steps. And I will be starting at the very beginning of game development. So if you already know some pygame, it's quite safe to start a bit further down and skip ahead. But if you don't, let's start talking about how games work on a theoretical level, because that's what we need to understand how pygame works. To create any kind of game, you need two foundational concepts. Number one is that you're able to draw a picture and update the picture. And this is how any game works, that you start by drawing one picture and then you update this picture. So for example, if the player moves to the right, then you draw the picture of the player a little bit further to the right on each different frame. And if you're doing this fast enough, then this looks like a fluid motion. But if you are just drawing things, then you have a movie, you don't have a game. And that brings us to the second part, that you need some kind of game logic that informs where stuff has to be drawn on the screen. And in here you want to take something like player input, or get timers, or enemy logic, or the input from other players if you're playing a multiplayer game. And these two concepts have to work closely together, so that you are pressing a button to the right, then you have some code that updates the position of the player, and then the game draws the new position on a new frame. So these two concepts are the foundation of any video game, and you are going to see them in basically any game development. And this is basically all we need to implement all of this in code. But there's one more problem. By default, Python isn't good at either of these things. When you use Python, you're mostly constrained to the console when outputting information. And for the input, you only really have the input method, which stops the code when you try to get player input, which is terrible for video games. So for both major steps that you need for game development, vanilla Python does not work all too well. Okay, it's not that bad, because you have lots of different modules that can help you with that. The three most famous ones are Pygame, Piglet, and Python Arcade. And they all work on roughly similar lines, although there are some differences. The one I'm going to use is Pygame, because it's the most popular one and the one I got used to be honest. But the other two libraries would work just as well. Do check them out, I would really recommend them, all of them are quite fun to develop in. And you could also use something like Godot, which isn't just a module for Python, it's an entire game engine. And it doesn't theoretically use Python, but it uses GDScript, which is basically Python with suspicious sunglasses and a trench coat. If you can write Python, you can write GDScript. And the Godot game engine has lots of convenience features that you can use. But none of that really matters, we are going to use Pygame, and it's quite a straightforward library, so let's start talking about that. And obviously the very first thing we need for Pygame is to install the module, because it's an external one. So if you're on Windows, open the PowerShell, if you are on a Mac, open the terminal. And in either case, type pip install Pygame, then you should be seeing an animation that Pygame is being installed. This should be quite a straightforward thing. But with that part covered, let's talk about how to start up Pygame. Before you can use Pygame, you always have to initialize it, and this happens with pygame.init. And once you're finished with your game and you want to quit Pygame, you have to uninitiate Pygame. And that happens with pygame.quit. So any game logic has to be between these two lines. And they're quite simple, it's literally just that. So how can we draw stuff in between? Well, the most fundamental concept is a display surface. And this is basically a canvas we can draw on. And once you have this canvas, you could actually run your code and see a black screen for just a second. But it would close immediately, because at this stage, you only told Pygame to create a canvas. You did not tell it for how long to keep it open. So Pygame creates a display surface, and then on the next line of code, it doesn't know that it's supposed to keep it open. So it's closing it again and ends your program. And to keep it open, what we need is called a game loop. And in this game loop is what I explained earlier. This is where the actual logic of the game happens, and also by the end of this game loop, we are drawing whatever frame was created by our game logic. So if we were to create in here, let's say a game character and move it to the right, then we will create a new frame with different information and draw it at the end of this loop. And that brings us to the first part that we need to cover in this game loop. That we need one line of code that draws whatever frame was created inside of this game loop. But besides that, we are also going to need a second part at the very minimum. And that is called the event loop. And what this one does is it looks for events. And events in most cases are player input. For now, we are not going to draw anything, so our resulting frame is always going to be black. But we can add lots of stuff to this later on. For now, let's go into the code and let's actually implement all of this. So here I'm in my code. And the very first line is that I have to import pygame. And if you're executing this code, this should work and give you this message. That pygame 1.9.6 and hello from the pygame community and the link. If you get this far, you have installed pygame correctly. And 1.9.6 is the latest stable one. Now, as I said before, the first thing we need is pygame.init. And this one initiates pygame. And at least for now, you don't have to know what that means in detail. So now we've initiated pygame. With that one done, we have to create a display surface. And this one needs to be stored in a variable. That is usually called screen by convention. You could call it something else, but screen is what you do see everywhere, so I would recommend using this one as well. And to create a display surface, we need pygame.display.set mode. And you could pass in quite a few arguments in here, but the one that you absolutely need is a tuple or a list with two pieces of information. And that is the width and the height of the screen. I'm going to go with 576 and 1024. So the canvas we are going to draw on is 576 pixels wide and 1024 pixels high. And the reason I've chosen those dimensions is because they work really well with the size of the files. So the background image, for example, is exactly half the size of these two. So we can just scale it up twice and have a perfect background. And since Flappy Bird was designed almost a decade ago for phones, all the image files are quite small. So I have to scale them up to have at least some kind of decent resolution. But you could basically pass any kind of number in here, depending on what you need for your game. But alright, now we have a canvas to draw on. And if I run the code now, we can see a black screen for just a second. And this is what I explained earlier, that if you run the code at this stage, pygame creates a display surface for just one line of code. And after this line, it doesn't know what to do with it. So it just finishes the code and closes all of this. So to maintain it, we are going to need our game loop. And this is literally just while true. So the code runs perpetually and we have to break it from the inside. And the first line we need in here is pygame.display.update. And what this one does is it takes anything that was drawn in this while loop before it and draws it on the screen. So if we draw in here, let's say image of player 1 and background image, if those two were actual images, update would take both of them and draw them on this display surface. Obviously right now we don't have any of them, so it's just going to be black. And also, if you were to run this code right now, you would not be able to close it. You would have to go to the task manager and close it from there. The X button at the top of the screen would not be working, so be aware of that. And to make it work, we need our event loop. And this is literally just a for loop that runs on every cycle of the while loop. So this usually looks like for event in pygame.event.get. So basically what happens in here is that pygame looks for all the events that are happening right now. And this could be something like you moving your mouse, or you pressing a button, or you closing a window. It could also be a timer, for example, that only triggers every second or so. And pygame catches all of these. And then inside of it, we can work with all of these events. And to look for specific events, you have to look for a specific type of event. And for now, the one type we are going to look for is pygame.quit, which is shorthand for closing the game with the X button at the top of the screen. So I need pygame.quit, all in uppercase letters. Oh, and I need an if statement. So if this is the case, then we want to run some code. And the code we want to run is pygame.quit. So we're doing the exact opposite we have done here. We are uninitializing our game. And this is literally the most basic setup you can have for pygame. If we run our code now, we are getting an error message because I made a typo, and double equal sign. So we are checking if they are equal. Okay, let's try this again. Now we can see a black screen. It is 576 pixels wide and 1024 pixels high. And it's just black because we're not drawing anything. And I can close this And if I close this, we're getting another error message. But that is expected. And the reason for that is that when we are calling pygame.quit, this while loop is still not completely ending. And we need another line of code to end it properly. And for this one, we have to import sys. And sys is giving us some access to system modules. And the only line we need from it is sys.exit. And this line basically makes sure that we shut down our game completely no matter what happens. So if this one is run, our code most definitely is going to end. So now if we run it again, we have the same output, we see a black screen with the same dimensions. If I close it now, then we are properly ending the game. So now you have learned how to draw a basic black screen. Congratulations. But there's one more element we need that is going to get quite important. And that is that right now we have no control over how fast this game runs. And let me run it again. So right now what it looks like is that we are seeing one solid black image. But as a matter of fact, we don't. Instead what we see is that Pygame draws a black screen multiple times per second. And I have no idea how many times per second it does that. And we do need some control over that, and that is really important for video games. And you might have heard of it, it's called a frame rate. And frame rates for video games are actually really important because they influence how fast our game runs and how fluid motions are. And let me explain what this means. Imagine you have an image that you want to move from the left of the screen to the right of the screen. So in every single cycle of our game loop, we are moving it 5 pixels to the right. And now how fast our game loop updates is really important. If it updates 100 times per second and we move 5 pixels on every single cycle, then we are moving 500 pixels in this 1 second. However, if our game loop only runs 10 times in a second, then we only move 50 pixels. So effectively we're moving only 1/10 of the speed, which would give us very different experiences depending on what kind of computer we are running our game on. And later on, when our game becomes more complex, we might end up in one part of a game where it's really busy, where the game slows down, and another part where the game runs really smoothly and the game speeds up immensely. And then the player's speed would be very different and everything would run at different speeds, which would be incredibly confusing. So what we have to do in our game is to limit the frame rate, so that our game can never run faster than a certain amount of frames, which in my case is 120 frames. Because this is quite a high frame rate and looks very fluid. But anything over 30 frames should be fine. And to implement this kind of logic, we need a clock object that I'm going to create up here with clock equals pygame.time.clock. Sure that you have an uppercase letter for the clock. And this clock object can help us do lots of different things. The one thing we need for now is to limit our frame rate. And this happens down here. And what we need is clock.tick. And into it we have to pass the amount of frames we want per second, which in my case is 120. So when this game runs, it is never going to run faster than 120 frames per second. It can run slower though, which is something we can't immediately control because this one is influenced by how much stuff is on the screen and how well your computer can cope with it. So in your code you have to make sure that your game never runs too slow, which basically means that not too much happens on the screen at the same time. But in our case, since Flappy Bird is so easy, you are not going to have problems with that. If I run off this again, we still see the same black screen, which, well, looks boring. So let's actually put stuff on it. And that brings us to the next topic, and that is to put images on the display surface with regular surfaces. And here's how that works. In Pygame, you have two kinds of surfaces. One is called the display surface, and the other is called just a surface or a regular surface. It's usually just called a surface. And these two are kind of similar, and they have lots of similar methods that you can apply on them. However, there are two major differences. Number one is that you only ever have one display surface. However, you can have as many regular surfaces as you want. And number two is that only the display surface is shown by default. You can have all the regular surfaces as you want, unless you put them specifically on the display surface, they would not be visible. But generally what surfaces do is they give you a new layer that you can put stuff on. So for example, when you import an image, this image will be created on a new surface. And then this surface you could put on the display surface. And then it would be shown to the player. And let's actually do that right now. And this is bringing me to my game folder. And in our game folder, we have two files and two folders. One has images, the other has sound files. And you can find the same folder in the description for this video. And I am also going to put a link in the description on where I found all of these files. And it is important that all of these are in the same folder, just to make it easier to import them. But let's import our very first image. And all the images are in the asset folder. And when we import an image, it's going to be put on a new surface. And this surface, just like the display surface, is stored in its own variable. And the first image I want to import, I'm going to call BG surface, short for background surface. And how to import something is with pygame.image.load. And now we need the file destination. In my case, this is assets/background-day.png. So now we have a new surface with this image on it. And if I run the code, you would not be able to see it, because we didn't put it on the display surface. And all of that happens in our game loop. And the command we need is first our display surface variable. So this screen here, and the method we need is called blit. And I have no idea why it's called blit. But what this one does is it puts one surface on another surface. And we need two arguments for this. The first one is the surface we want to put on the screen surface. And in my case, this is BG surface. And now we need the location where we want to put it. So this is an X and a Y position. And this is going to be confusing. So let me first show what I'm doing, and then I'm going to explain. So I'm going to put this file at location 0 and 0. So if I run the code now, we should be able to see something. Exactly. We can see the background image, and right now it's exactly half the size of our screen. And we are going to double the size in just a bit. But for now, let's talk about what we have done here. The first thing you have to realize is that when we place this surface on the display surface, is that we are moving the top left of this surface. So when we put it on position 0 and 0, we put the top left of the surface on the position 0, 0 on our screen surface. And this is always the point you move when you move surfaces. You always control the top left. But that brings us to the second question, that why is 0, 0 the top left of our screen, which is kind of confusing. But in Pygame, this is where the origin point is. And to better understand this, think back of your high school days, where you had a coordinate system that has an X and a Y axis. And the origin point in high school was always the bottom left, so that when you increased X, you moved to the right, and when you increased Y, you moved upwards. In Pygame, this is kind of similar, but slightly different. The X one is still the same, that if you increase X, you move to the right. However, the Y one is inverted because the origin point is in the top left. So if you want to go down, you have to increase Y. And if you want to go up, you have to decrease Y. And this is immensely confusing for basically everybody. And it is going to take you some time to get used to it. But usually people get used to it in a couple of days. So just be aware of that. But let's talk in a bit more detail about the dimensions of our screen. So right now, the top left is 0 and 0. So the left side is 0 and the top side is 0. And if you were to go all the way to the right, you would get to 576. Exactly the point we have specified earlier when we called set mode. And the bottom of our screen is 1024. So these 4 points are the boundaries of our screen. And we can move around on any point on the screen. So when I go back in my code, and let me close this, and change any of these points, I can move around in this coordinate system quite easily. So let's say, let me go to point 100, and let's say 200. Then I go 100 pixels from the left and 200 pixels from the top. And if I run the code now, we can see we have moved a bit from the left and quite a bit more from the top. And here's the thing, we increased Y, but we went downwards, which really is a confusing thing. And if I would set this to -200, we would be moving slightly outside of the screen. So now the top left of our screen would be 100 pixels from the left, but -200 pixels from the top. And this is all we need. Let me put all of this back, because we want to keep this at position 0, 0. So this is how you position something on the screen. But right now, this thing is only half as big as it needs to be. So we need to take this surface and scale it up by 2. And Pygame has a specific method for that. And that method is called pygame.transform. transform, and it's called scale to x. And now we pass in bg surface in here. So this entire method here takes one surface and it doubles the size of it. And then it's going to return a new surface. So we are going to need a variable to store this new surface. And this one can also be bg surface. So let me explain what happens here. We first import our surface and we store it in this variable. Then on the next line, we take this surface and double it in the size and override this variable with the scaled surface, because we only need the scaled up version. And with these two lines, and I run the code now, we should have a proper background picture. So this one's working quite well. And you could actually combine these two lines quite easily. So if I just copy and cut this entire thing and paste it in there, this one would also work quite well. But I think this one looks cleaner. There's one more thing we do need, and that is .convert at the end of our import line. And convert isn't strictly necessary, but what it does, it converts the image into a type of file that is easier to work with for pygame, which basically makes it easier for pygame to run our game, and it allows us to run the game at a faster pace. But when I run the code, you are not going to see any change. But if the game became more busy, this convert would help pygame to run the game at a more consistent speed. But, alright. Now we're able to put images on our screen, which is a pretty good starting point to move stuff on the screen. And I'm going to start this by moving the floor on our screen. So when you look at the original Flappy Bird, on the bottom you have a floor that continuously moves to the left, which is what we're going to take care of now. And let's start by just importing the image. And I've called this one floor surface. And we're importing it in just the same way. So pygame.image.load. It is also in the assets folder, and it is called base.png. And also, just as before, we have to convert it to make it easier for pygame to run. And let's put this thing on the screen first. So we need screen.blit again. And this time I want to put our floor surface. And just for a start, let's put it at position 0 and 0. So this line is exactly the same as this one. And if I run the code now, we can see the floor right at the top. And just like the background picture, it is half the size it needs to be. So the first thing we need is to scale this thing up, which is the exact same logic, just as again, pygame.transform.scale to x and floor surface. So if I run it now, we can see a properly sized floor, and we have to move it downwards. So in this line, I'm going to put the floor at position 900. So if I run our code now, we can see the floor at the bottom, but it is entirely static right now. So how can we move it? Well, it should be quite obvious, because all we need to do is update this point by a tiny amount on every single cycle of this while loop. So let's say right now it's 0. On the next cycle, I want it to be at position 2. Then I want it to be at position 4, then position 6, position 8, and so on. We move it by tiny increments, and because these increments are so small and all of this happens so fast, then to us it is going to look like a fluid motion. And to get this kind of logic, I'm going to create a new variable that I call floor x position. And by default, this is going to be 0. And let me replace this one down here with floor x position. So this is going to get us the exact same result, because in the variable we have the integer 0 that we had before, so no change. But what we can do now is before the line, floor x plus equal 1. And if I run the code now, it is slowly going to move to the right. And this is something you really have to understand about video games, that on every single cycle of this while loop, we are drawing all of this over and over again. This image is never static, it is always redrawn. And what effectively happens here is that at the start, this floor x position is 0. But on the next cycle of this while loop, it's going to be 1. And then it's going to be 2 and 3 and 4. So every time we are drawing this line again, this position increases by a tiny amount. And then the outcome is that to us, it looks like it's moving. And just to illustrate this a little bit better, let me increase this number drastically and let me lower the frame rate to, let's say, 1. And now you can see quite a bit better how this is going to look. Now you can see a very slow movement that every single cycle of this loop, this is going to move a bit further to the right. So let me remove all of this to normal. So this is the basics of animation. And in our case, this one here would move to the right, but I want it to move to the left, which in my case is the exact other direction, so -1. So let me run this again, and this looks like a decent speed. But obviously the floor is disappearing, which is not ideal, so we can work on that one now. And here's the logic how I'm going to fix this. I'm going to have 2 floors right next to each other, and both of them are going to move at the same speed to the left. However, if the right floor is at position 0, so on the left side of the screen, then I'm going to move the first one to the left side of the screen and the right one even further back. And how this looks to the human eye is a continuous movement. And I'm going to put all of this into a dedicated function, just to keep this game loop a bit cleaner. And I'm going to call this function draw floor. And at the top of our game, I am defining draw floor, and it does not need any arguments. And in here, I want to draw or put this surface on the screen. But I want to put 2 surfaces on the screen. So let me copy this entire line. And I'm going to add plus 576 on the x-axis. So what does that mean? You might already see the similarity. 576 is the width of our screen. And the width of this floor is also 576. So we're drawing this floor on the left side of our screen at position 0, and we're putting this floor on the right side of this initial floor surface, so that both are right next to each other. And since floor x position is still decreasing, both are going to move at the same speed to the left. And let's try this now, and we should be able to see a longer moving floor for quite a bit. But it is still going to disappear at some point. There we go. So this is what we have to fix. And how I'm going to fix this is after the draw floor function, I want if floor x position is smaller or equal to -576, which basically means if the left surface is too far to the left, we are going to do something. And what we're going to do is floor x position is going to be 0 again, exactly where we started. And if I run this now, we should be able to see a continuously moving floor, because once this floor is going too far to the left, it's being reset to this point here on the left side of the screen. And since all of this is happening so fast, to us it just looks like it's continuously moving. We don't ever actually see the transition. And with that, we have our basic animation. So that's a pretty good start. And now that we have a background, let's start talking about our bird. And we are going to import the bird in just the same way as we imported the background and the floor. However, when we put the bird on the screen, we are going to need a different process, although it's not too different. But there are a couple of reasons why we need to change the process a little bit. Number 1 is that for our bird, we want to check collisions, and surfaces by themselves cannot check for collisions. Reason number 2 is that we want to have more control over how we place the bird, because when we are going to rotate it, we want to rotate it from the center. But with surfaces, we always move the top left point, which wouldn't allow us to rotate from the center. And because of these 2 reasons, we can't just use surfaces. They're going to be part of it, but we are going to need another tool to implement these 2 functionalities. And the tool to get both of them is called a rect, short for rectangle. And a rectangle is quite a simple but really powerful thing. And well, it literally is just the shape of a rectangle. But this shape of a rectangle can do quite a few different things. Number 1 is that you can use lots of different rectangles to check for collisions between the rectangles. And later on in our game, both the pipes and our bird are going to be surrounded by a rectangle that you can't see, but we are going to use them for our collisions. And number 2 is that when you place a rectangle on the screen, you have lots of different points that you could place on the screen. Here are all of them. So while we always place the top left of the surface, for a rectangle, we can place the center or the mid left or the bottom right, lots of different points that we can place on the screen. And all of these points have an X and a Y coordinate, so you could literally place them anywhere on the screen. And there are two ways to create rectangles. Number one is that you can use pygame.rect and implement an X and a Y position and a width and a height. And then you have a rectangle in a certain position. But you don't use them that way all too often. Instead, what you would rather do is that you are taking a surface and you put a rectangle around it, so that this rectangle is going to get the exact same dimensions of the surface. And then you can place this rectangle somewhere on the screen. And then you could put the surface on top of this rectangle. And if you approach it like that, you can check for collisions and you can rotate the surface in any way you want. And this is exactly what we are going to do. So let's actually get into our code and implement all of this. So here I'm back in my code. And the first thing I'm going to need is to import the actual picture of the bird. And I'm going to call mine bird surface. And we are going to import this just as usual. Pygame image.load. It is in the assets folder. And in that folder, there are 3 different versions of the image for different cycles of the animation of the bird flap. For now, we are just going to use the mid flap, but later on, we are going to animate the bird. But for now, I'm just going to use bluebird-mid flap.png. And as always, I'm going to convert the entire thing. And then on the next line, same as before again, it's pygame.transform.scale to x, and we pass in our bird surface. So far, exactly the same process, no change here. But now we're going to do something new. I will create a new variable that I call birdRect, short for bird rectangle. And this one is going to be birdSurface.getRect. And what this one does is that it takes this new surface and puts a rectangle around it. And the argument we pass into it is where we want to place this resulting rectangle. And the first thing we have to do here is to grab 1 point from the rectangle. In my case, this is going to be center. And now this needs a tuple with an X and a Y position. And for now, let me put it at 100 pixels from the left. And now we're going to put it in the middle of the screen. So literally half of that dimension, which is 512. So now we have a rectangle that has the width and the height of this surface, and the center of this rectangle is on this coordinate point. We can't see it right now because we first have to draw it in our game loop. And let's do that. So in the game loop, I'm going to add screen.blit just as before. And again, I want bird surface. But now instead of putting a tuple, I just put in our bird rectangle. And this should be working. And yeah, here we go. We have our bird. But instead of just having a bird, we also have a rectangle around the bird. And we can use that rectangle to check for collisions and also to rotate this image. But before we get into that, let's first give it an animation so that it falls down and we can jump or flap or however you want to call it. And let's start by making it fall down. And to make something fall down, we need gravity. So let's do it up here. I'm going to create with a comment a section that I'm going to call game variables. And the first thing I need in here is gravity. And gravity for now I'm going to put at 0.25. And this has no resemblance to the real world. I am literally just picking numbers that look good on the screen. And besides gravity, I want a second variable that I'm going to call bird movement. And by default, this is going to be 0. And this is the variable I'm actually going to apply to the bird later on. So effectively what we're going to do later on is we're always going to add this gravity on every frame to this bird movement. And then this bird movement is going to move this bird rectangle down. And then if this bird rectangle goes down, then this bird surface is going to be put on different positions on the screen. Sounds complicated, but let's actually implement this. And let me first put some white space in there. So the first thing I want to do is bird movement plus equals gravity. So bird movement on the first cycle of this while loop is going to be 0.25. On the next one is going to be 0.5, then 0.75, then 1, and so on. So this number is slowly increasing, which is a pretty good start for gravity. And now we have to apply that bird movement to our bird rectangle. And this we can do with a different point that I haven't shown yet, because rectangles have quite a few more points, and you can see all of them on the screen right now. And what all of these points have in common is that they only move in one axis. So for example, center Y is only up and down and center X only goes left and right. And they only use the X and the Y position. So you couldn't use these points to place the rectangle, but you could use them to move the rectangle. And if you move any of these points, you move the entire rectangle. And this is exactly what I'm going to do, because what I want is bird_rect dot center Y plus equals bird movement. So if I run the code now, we can see our bird falling down. And well, we don't have anything to counteract it. So the bird just keeps on falling down and we can never see it again. And at some point, pygame starts to have bugs and the bird starts at the top again. But that is not going to be a problem for us. We're going to fix that one later. And let's actually work on that for now. That we want to give our bird the ability to move upwards. And for that, we have to check for keyboard input. And this is going to happen in our event loop. And we are already checking something in here, that if the player closes the game. And in here, we now want to check something else. And that is if event.type is equal to pygame.key down, which checks if any of the keys of your keyboard have been pressed down. And now we have to check for a specific key, which you check with event.key. So this event, when it's triggered by a key down, is going to have another attribute that is key. And pygame has lots of different names for the different keys. And the spacebar is called pygame.key space. And this is the one we want to check. So now, if we press space, let's now just test if this is working. I want to print, let's call it flap. So we run this again, and if you look on top, I press space and we can see flap. So this one is working well. So what we have to do is replace this one with some actual code that makes our bird jump. And to make our bird jump, all we really have to do is make this bird movement negative. Because if it is negative, our bird is going to move upwards. And it's only going to move upwards because at some point, this gravity, since it's continuously increasing, is going to move the bird downwards eventually again. So what we want to do is bird movement minus equal, and let's say 12 for now. And let's test this. So this is kind of working, but there's one problem with that. And let me press, you can kind of see what happens. Let me try to get the bird on the screen. Okay, it doesn't work. So the problem here is that this bird movement right now doesn't really work. And there's a fairly straightforward reason of why it doesn't work. And the reason for it is that this bird movement has to be 0 when we are triggering this line here. And let me just illustrate this. Let's say we have moving gravity for a few seconds. So that gravity is something like 20. Now when we press our space button and we just subtract 12 from this, our bird is still falling down. It is just falling down at a slower pace. And only if we press space again, then we are at a negative speed, so we are moving upwards. However, now if we press it again, we are jumping even further upwards. So the faster we are pressing space, the higher we are going to jump. And at the same time, if gravity has been running for quite a while, then if we press space, we're not going to jump at all, we just fall at a slower speed. And all of this can be prevented by just turning bird movement to 0 before we are going to jump. So that effectively, when we are going to jump, we disable all the effects of gravity so far and just apply the speed of the jump. So if I start this now, this should be working much better. So now every time the jump height is going to be exactly the same, which is exactly what we want. But we still have our effects of gravity, and this seems to be working quite well. Cool. And now that we have our basic bird, let's add the pipes. And then we have a basic game, and then we can refine things after that. And the pipes are going to be put on the screen in a similar way compared to the bird. We are still going to import a surface, we are putting a rectangle around the surface, and then we place the surface on the screen wherever the rectangle happens to be. But there's going to be a bit more logic, because we don't just want one pipe, we want the pipes to continuously move from the left, and we also want to spawn new pipes every couple of seconds. And we can implement this fairly easily, but we are going to need a couple of new things. But let's go through this step by step. And let me start by just importing the pipes. So here we're back in our code, and what I want is to import what I'm going to call pipe surface. And just as usual, pygame.image.load. And the pipes are also in the assets folder, and they're called pipe green.png. And then let me just copy this entire line, and this is going to be pipe surface and pipe surface. So again, same process as usual. But now it would be kind of pointless to put this surface into a rectangle, because we don't just want to put this one surface on the rectangle, we want to continuously put it on the screen. And here's how I'm going to approach this. I'm going to create a new list that I'm going to call pipe list. And into this pipe list, I'm going to put lots of rectangles that are continuously moving leftwards. And then in our game, we are using these rectangles to place a new surface on each of these rectangles. And since all of these rectangles are moving leftwards, it looks like the pipes are moving leftwards as well. And we're also going to create a timer that is going to create a new pipe every second, which we're going to create in just a second. But let's start by just creating an empty pipe list. So pipe list, and for now it is literally just an empty list. And into this later on we are going to put lots of rectangles. And how we are going to create one of these rectangles is by using a timer. And timers in Pygame actually work fairly simple. The first thing we need is a new variable that I'm going to call spawn pipe. And somehow by convention these are always typed in uppercase letters. You don't have to do it, but it's just good practice, I suppose. And what we want here is pygame.user event, and this also has to be in uppercase letters. So now we have a user event, and this user event kind of works like the events in our event loop, except this one is not being triggered by clicking a button or by moving the mouse. Instead, it is going to be triggered by a timer. And this timer we're also going to create here. And we're going to create this with pygame.time.set timer. And now we need our event, which is spawn pipe. And now the length of the trigger. So how much time we want to pass since it's going to be triggered. And in my case, I'm going to go with 1200. And this is in milliseconds. And 1 second has 1000 milliseconds. So what we're looking at here is 1.2 seconds. So now we have an event that is going to be triggered every 1.2 seconds. But we don't have any code for it. And this is also going to happen in our event loop. So I have to create a new if statement here that if event.type is equal to spawn pipe. And just to check if this is working, let's print pipe. And yeah, there we can see. A bit over once a second, we can see that Python prints pipe in the console. So this one is working quite well. We are making progress. So now every time this event is triggered, we want to create a new pipe and add it to this pipe list. And this I'm going to do for now with pipe list.append. And in here, I'm going to use a function that I'm going to call create pipe. And what this one is doing is it returns a new pipe with the dimensions of a surface. So let's create this function here. And for that, we're going all the way up and create a new function that I'm going to call create pipe. Doesn't need any arguments. And let's create a new variable here that I'm going to call new pipe. And this one is going to work just like this line down here, where we use a surface, then get rect, and then place the resulting rectangle somewhere on the screen. So what I want in here is pipe surface.get rect. And now we have to place this somewhere on the screen. And for now, what I want to place is mid top. So we take the middle of the top of this rectangle and place it somewhere. And for now, let me place it right in the middle of the screen. So X is 288 and Y is 512. Literally half of these dimensions. And once that's done, I want to return new pipe. So now, whenever we are using this event, it is going to create a new pipe and it's going to store it in this list. And let me actually print the entire list every time this is running, just to check if this is working. So we can see one rectangle, we can see a second rectangle, then we can see a third rectangle, and so on. So here we can see we have one rectangle, then we have 2 rectangles, then we have 3 rectangles. They are all in the same position for now, but we are going to work on this in just a bit. But for now, we do know it is working. But we don't just want to keep all of these rectangles in a list, we actually want to use them. So let me get rid of this. And I'm going to create a new function that I'm going to call move pipes. And well, this function moves pipes. It's quite obvious, I think. And this function is going to get a parameter that I'm going to call pipes. So what I'm going to pass in here is the list of all the rectangles of the pipes. That is going to get the new pipes every time we are running this event. And what I want to do is for pipe in pipes. So for each rectangle of a pipe inside of this list. And what I want to do is pipe dot center x minus equal, let's call it 5. So basically what this function does is it takes all the pipe rectangles and moves them to the left by a little bit. And once all of that is done, we want to return pipes. So what basically happens is that we are taking a list of pipes, then we go through every single one of these pipes and move them to the left by a tiny bit, and then we're returning a new list of pipes. So all this function really does is it influences all of the different rectangles and then creates a new list of new rectangles. And in our game loop, let me give some space. Let's do it below the bird. And let me actually give some comments about what we're doing, because that is going to make it much easier to see what's going on. Let's just call this bird. So, and let's call this actually floor. Now I want our pipe list is going to be move pipes and pipe list. So we take all the pipes in this pipe list and we're going to move them by a tiny bit and then override this existing list. And with that, we have moving rectangles, but we still haven't drawn them yet. And that I'm going to do afterwards. And this is going to be happening in a function I call draw pipes. And well, it draws pipes, just like it moves pipes. So we create a new function that I call draw pipes. And again, I'm going to pass in pipes. And now, kind of like the logic before, we want to cycle through every single pipe in this pipe list and draw it on the screen. So this happens again for pipe in pipes. We want to go screen.split. And now we just take the surface we have created earlier, so this one here, which is pipe surface, and now pipe. And now we should actually be able to see all of our pipes. And we cannot, because I forgot to pass in our pipe list here. Quite an easy fix. Now we can see that the pipes are spawning in the middle of the screen. Obviously, it's right in the middle of the screen, it doesn't help too much. So what we have to do is spawn them further to the right. And let's actually do this right now. And this is going to happen in here. When we create the pipes, they're going to be spawned at position 288, so in the middle of the screen. And instead, what I want to do is to go a bit outside of the screen. Let's say position 700, so we have some wiggle room. And if I run the code now, we can see our pipes coming in from the right. They all have the same height right now, which isn't great, but we do have a start. Also, well, we need a top pipe as well. So let's work through all of these points. And the first thing I want to work on is that we have pipes with a different height, which means we need random numbers, which means we have to import the random module. And I'm also going to create a new list that I'm going to call pipe height. And these are all the possible heights that our pipe can have. And I'm going to pass in here 400, 600, and let's say 800. So these can be the positions of our pipes. And every time we create a new pipe, we want to pick a random number from this list. And this is going to happen all the way at the top when we create our pipe. And what I want is random pipe position. Let me store it in its own variable. And what I want to do is to pick a random item from a list, which happens with random.choice. And in here, we have to place our pipe, how would I call it? Pipe height. It is really hard to name variables for me. Okay, so now what's happening is that we are picking a random number from this list. And when we place our pipe, we want to pick that number. So instead of having 512, we want random pipe position. So let's try this now. And we should have different height for our pipes. There's one, there's another one. This seems to be working. Yeah, there we go. Now we have pipes with a different height. So this is a pretty good start already. So now we can work on having a second pipe on top. And how I'm going to approach this is that in this function, I'm not going to create one pipe, I'm going to create two pipes. With one pipe being in this random position and one pipe being above that position. So this rectangle here effectively becomes the bottom pipe. And let me rename this just to be clear on the variables. And now I want to create a top pipe. And this pipe is going to work in quite a similar way compared to this other pipe, with some key differences. The first thing is that we don't want to place the top, instead we want to place the bottom of this rectangle, so that we make sure it's moving upwards from that point, not downwards. And then I don't want it to be on the same Y position, instead I want it to be a little bit higher. So I just subtract, let's say 300 from this, so that there's some space between the two. And once this is done, I want to return both the bottom pipe and the top pipe. And this is going to need another change. That now, since we're returning two variables separated by a comma, we are returning a tuple. So we have to unpack this tuple, or at least do something else with it. We couldn't just append it to another list. Instead, what we're going to do is to use extend, which is taking this list and extends it by whatever is returned by this, which is a tuple with two elements. And with that one, this should still be working. So let's try. And it's working, and we can see two pipes. And obviously the top pipe is facing the wrong direction, but we can work on this in just a bit. But we're already doing quite well, so we can see the basic outline of our game. So let me close this. And now let's work on reversing the top pipe. And this is going to happen in our draw pipes function. And let me minimize all the other functions so we have a bit more space. So in here we have to add some extra logic to flip the pipe if it is in a certain position, which we can do quite easily. So what I want to do, if pipe.bottom is greater or equal than 1024. And if this is the case, we know that the pipe is on the bottom. So basically what happens here is if the bottom of this pipe is outside of the bottom part of the screen, so it is greater than this 1024, then we know it is on the bottom of the screen, because the top pipe would never reach that position. So if that is the case, then we want to draw it in this way as we have done before. But if that is not the case, then we want to do something else. And what we want to do is to create a new surface that is being flipped. So I'm going to call this flip pipe, and pygame has a specific method to flip a surface, which is pygame.transform.flip. Flip. And it needs a surface, as before. And then we need two more arguments, both of which are booleans. The first one is if we want to flip it in the x direction, which we do not. So this one is false. And the second one is going to be true because this one is flipping it in the y direction. So this one is what we actually want. So now that we have a new surface, we want to put this new surface on the screen. So we want to use screen.blit, and this is going to be pipe surface and pipe. And let me try this. And now it is still not working. For the simple reason that I passed in the wrong surface. This has to be flip pipe, not pipe surface. So let's try it again. Here we go, this looks much better. So now we have proper pipes. I don't know why they're all the bottom. Okay, just a bad roll. So now they're more varied. So it is working. So let's work on collisions now. And collisions are quite an easy thing to do once you have rectangles. Because right now on our screen, we have a rectangle around the bird and with a rectangle around each of the pipes. And all we have to do is to check if any of these rectangles are colliding with each other. And the method we have to check for collisions between rectangles is called collide rect. And this one either returns true or false. False if there's no collision, true if there is a collision. And this we can use to run some code if a collision happened. So let's implement this. And in our code, I want to create a new function that I'm going to call check collision. And again, I want to pass in our pipe list in here. And now in here, I want to go through all of the pipe in pipes. So just as before, we're looking at every single rectangle inside of this pipe list. So we can work with every single rectangle inside of it. And now we have to do something new with these pipes. We want to check if any of them are colliding with our bird. So what we want to do is bird rect.collide rect pipe. So what happens here is that we are taking our bird rectangle and we're checking if this bird rectangle is colliding with any of the pipes in this pipes list. And if that is the case, this is going to return true. So we can use it in an if statement. And for now, let's test if this works. Let's say collision. And obviously right now this is not going to work because we're not calling the function, which I'm going to do, let's do it down here. So now let's try this. And let me hit the pipe, and there we go, we have collisions. So we know when our bird hits a pipe. And I also want to add something else in here. And let me demonstrate why we need another if statement in here. So I run the game again, and I can just go outside of the screen and fly above all the pipes. And could basically play the game forever, although it just doesn't make sense to play it like that. So what we want to do is if the bird gets too high or too low, then we also want to trigger a collision. And for this, we don't actually need collisions. We just need to check if the top of the rectangle of the bird is too high up or if the bottom of the rectangle is too far down. And generally, it is pretty good practice to use collisions as little as possible, because calculating collisions is quite difficult and takes some processing time. Whereas if you just check for a specific position, this is much easier to do. And especially in our case, since we don't need to calculate collisions, we shouldn't do it. And this is something that makes our game more efficient. In our check collision function, I just want to check if bird rect.top is smaller or equal, let's go with -100. So that you can go a tiny bit outside of the screen, but not too much. And if you get this far high up, you're probably gonna hit a pipe anyway. And we want an OR statement if bird rect.bottom is greater or equal. And here we do have to be a bit more precise, because we are putting our floor at a specific position. And what I want to do is whenever we hit the floor, the game is over. And we put the floor at position 900. So this one has to be 900. And if that's the case, let's for now just print also collision. And let me try this. So I just fall down and we have collision here. And the same should be if we leave the screen at the top. So this one is working, and now we have some collisions. And there's another thing I do want to talk about, that I have used smaller than and greater than, not equal to. And this is really important. That in video games you very rarely get exact pixel measurements. And it is really unlikely that, for example, the bottom of our bird rectangle is exactly on position 900. Instead, it is much more likely going to be at slightly below or above that point. So it might be at 895 and on the next one at 902. So it doesn't exactly hit it. So if we were checking for strict equality, this would not be triggering and our bird would be falling down, because the 2 points are not exactly the same. But instead, if we use greater than, then it's going to trigger every time. And this is a general principle in video games, that pixel measurements are never that precise, and you always want to have some wiggle room when you move something on the screen or when you check for collisions. And this is why I use greater than and smaller than, not equal to. And I actually did the same when I moved our floor. So here floor X position is smaller than -= 576. But in our case, since we always move by 1 pixel, this should be okay with equal sign, but this one is safer to work with. But alright, and now we actually have to do something with these collisions. And basically what I want to do is to turn the game on and off. So I'm going to create a new variable that I'm going to call gameActive. And if this one is true, our game is running. If this one is false, our game is not going to run. And then our checkCollision function triggers this and turns it on or off. And this would already be the starting point for our game over screen. So let's implement this one. So here I'm back in my code. And the first thing I want to do is to create a new variable that I'm going to call gameActive. And by default, this one is going to be true. And now in our game loop, let me minimize this as well. We don't have the event loop. We want to run all of this only if gameActive is true. The floor is always going to be there, same as the background. Those two can always be on the screen. But these two, the bird and the pipes, should only be on the screen when the game is active. And this is a simple if statement. So if gameActive is true, then we want to run all of this. And else we want to do something later. That's going to come in a bit. So if I run the game now, there should not be any change. So this still works the same way. We still get collisions. But now, if we put gameActive to false, we are not going to see anything. We can just see our background and our floor. So this one is working for now. Now we need to wait for this checkCollision to influence this gameActive variable. And this I'm going to do with return. That if either this or this happens, then we're going to return false and store this false in this gameActive variable. And if neither of these trigger, then we're going to return true. So what we want to do in our game loop, when we check for collisions here, I want to get the return value and store it in our gameActive variable. So in here, this should return false, and this should also return false. But if neither of these trigger, then I'm going to return true. So essentially what's happening when this function is running, Python first looks at this line here, and if this one is true, it's going to return false and end the function. If this is not happening, then it is coming to this line, and it checks if the bird is really high up or really far down, and if either of these is true, then it's also going to return false. And if either of these are returning false, then we are storing false in our gameActive variable, and if this one is false, the game loop or this part of the game loop is not going to run anymore. So we are effectively stopping the game. However, if neither of these are true, then we are returning true and the game continues. So let's try this. And we can still see our pipes, and this one worked, and now we're disappearing. So this one is working, but we can't restart the game, which is kind of annoying. So let's work on that for now. And to work on that, we will need to go into our event loop. Let me open it again and add some more code in here. And I'm going to do this right below where we check for key down. And here we want to check for another key press. And I still want to use the space key. So this is before, and let me actually copy this entire line. I still want to check for the same button. However, this time, I only want this to be true if the game is over as well. So I need to add another statement that if and gameActive is equal to false, and then I want to execute some code. So this entire if statement is only going to run if I press the space button and if the game is over. And we can actually change this key space here and gameActive, just to be sure. So this space button press is only going to trigger if our game is active, and this one is only going to work if the game is over. And now in here, if this is true, we want to set gameActive to true again. However, let me demonstrate why this by itself doesn't work just yet. So the game for now, it is going to work, but it's going to be buggy. So you can see that you can kind of see what's happening. That it should be working in a second again. There we go. And you can see lots of pipes. So basically what is happening here. When the game is over, our bird and the pipes are still in the same position. So when we start the game over again, our bird immediately is colliding with a pipe. So the game stops again and we're having a bug. And only if you press space multiple times, then eventually the bird moves a tiny bit forward every time and gets forward. However, because the bird is moving so slowly now, we are creating more and more pipes on the right. So once the web is moving normal again, we have a ton of pipes. So it's a start, but it's not working greatly yet. But we can fix all of this super easily, because all we have to do is put the bird back in its normal position and despawn all the pipes, which just means we empty the entire pipe list. And this we can do really easily. All we need is pipe list.clear, and we are going to need our bird rectangle dot center is going to be wherever it was when we created it, this position here. So now when the game is over and we are restarting it, then we are emptying the entire list, and we're also going to put the bird in its original position. So let's try all of this now. And this worked as before. And now if I press space again, let me show this. So now we can't see anything. If I press space again, this is working again, and we are restarting the game. But we did get an error there towards the end. And basically what happened here is that we never cleared bird movement. So when the bird is restarting, then we are still applying the bird movement, which can be quite a high positive number. So all we need to do is when we are restarting the game, we also want bird movement to be 0. And now this should be working. Let's try it now. And let's wait a couple of seconds. And now I start again. Now bird movement is still going to be 0. And we have a basic outline for the game that is just as infuriating as the original. And I have no idea why people really like this game. But alright, this is working. And now we actually have a basic outline of the game. Now we just need to add lots of different details to make it look prettier. And I'm going to start with our bird. And what I want to add is a rotation and a bird flap. And let's start with the easier one, the rotation. And I actually made an entire video about rotations in Pygame by itself, but they can be a tiny bit tricky. The really important thing you do have to be aware of, that when you rotate something in Pygame, it loses a tiny bit of quality, which is fine if you rotate something just once. And the way around it is that you have two different surfaces. One that is the original, that is not rotated at all, and then another surface that is rotated. And every single rotation always starts from the original point, so you effectively only rotate something once, and you don't really have any kind of loss in quality. But check out the other video, it explains rotations in much more detail. But all I want to do for my game is to create a new rotated bird surface and then put this on the screen. So all I want in our bird section of the code, and let me do it after gravity. Then I want a new surface that I call rotated bird. And this one is going to be returned from rotate bird. And I pass in the original bird surface in here. So we have to create a new function that takes our original bird surface, rotates it, and returns a new rotated bird that then is going to be put on the screen. So we don't want to put bird surface, we want to put rotated bird on the screen. And that's going to be another function that I called rotate bird, and it takes a bird. And in here, I create a new surface that I'm going to install in new bird. And to rotate something in Pygame, the function is called rotozoom, which we access with pygame.transform.rotozoom. And rotozoom can do two things. It can scale and rotate a surface. But in our case, we don't want the scale functionality, so we only use the rotation part. But the first one is always is a surface, which in my case is bird. And then I want the angle by how much I want to rotate it. And in my case, I'm going to use bird movement, because this one starts at 0. And if we go down, it increases. If we go up, it decreases, which we can use for the rotation. It's quite simple. So I just want to pass in bird movement in here. And I need the scale as the third argument, and this is just going to be 1. And once that's done, I want to return the new bird. And you could simplify this entire thing quite a bit. You could even use a lambda function to do all of this, but I think in my case this is the most obvious way of doing all of this. And this one should actually be working. Let's try. So there's one thing that is a bit weird. We have a black thing around our bird, but you can see a rotation, except it's very small. So let's increase it. So bird movement, let's say we go ×3. And let's try it again. So now the bird is rotating, but it's rotating in the wrong direction. So all we need to do is add a minus here. And this one should look a bit better already. And here we go. This looks much better. And this is a proper rotation. But we do have a black square around our bird, which isn't great. And the reason we have the black square around our bird is that when we are creating this new surface, it doesn't have any alpha values, which basically means that if Python sees something that is not supposed to be drawn on, it just draws it as black. But we don't want it to be drawn at all. And to do that, we are going to need, when we create our bird, to convert it to convert alpha. And now this surface should be working. There we go. So we just have to give it an alpha value, and then it's working. And that's a pretty good progress. So yeah, I'm really not good at this game. But never mind, doesn't matter. So now we have a rotation that is actually working quite well. We can close this one and never look at it again. Next up, we want an animation of the bird flap. And this one is going to get a tiny bit more complex. And let me explain how animations work in Pygame. Basically what we have to do is import multiple images and put all of these images into a list. And then in our game, we just want to cycle through these images consecutively. So we use image 1, image 2, image 3, and then go back to image 1. And each of them is at a different stage of a bird flap. So effectively what we want to do is import multiple surfaces, put them into a list, and then cycle through this list at a certain speed. Which we can implement actually quite easily. So I'm back in my code, and for now, let me just comment out all of this, because we are going to change it quite a bit. And there's going to be some typing, and I already prepared all of this before. So let me paste it in, and here we have 4 lines. We have bird down flap, bird mid flap, and bird up flap. And each of them loads an image and converts it with alpha. So kind of what we've seen before in this line here. But then immediately it scales up the image by 2 for each of them. So what we have done in this line here. And once that is done, it puts all the free surfaces into a list. So there's nothing complex happening in these 4 lines. We just import free surfaces, scale them up, and put them into a list. And I also want to create a new variable that I'm going to call bird index. And this one starts at 0. And I'm going to use this variable later to pick a specific surface from this list. And since we need a bird right from the start, I actually have to do this already. So I'm going to create bird surface just to keep the same name. Is going to get bird frames and bird index. So we just take this list and we pick a certain item from this list depending on what this number is going to be. And then I also want a rectangle around this, which I'm going to call bird rect. The same I had before, so we can keep the other names. And this is just going to be bird surface.get rect. And I can literally just copy what I had in here and pass it in here. So all of this should result in the exact same thing we had before. Let's try it. So we can't see any change, except that now our wings look slightly different. Because now we're using down flap, we don't use mid flap anymore. And if I change this to 2, we'll be using the up flap. So now our wings are upwards. So all we really have to do now is cycle through this list at a certain speed. And to do that, I'm going to use the same approach like I've done before with spawn pipe. I'm going to create a new user event that I'm going to trigger every couple of milliseconds. And every time this is triggered, it's going to increase bird index by 1. So I'm going to call this bird flap. And this is going to be pygame user event. And this has to be +1. So we don't create the same kind of user event, we want a different one. And if you wanted to create another one, this would have to be +2 and so on. And just as before, I want pygame.time.set timer bird flap. And let's go with 200 milliseconds. That seems okay. So we are going to change the index here every 200 milliseconds. And I think that should be fast enough. So now we have to go back into our event loop, and let me minimize this other stuff. And I want if event.type is equal to bird flap. And if that is the case, I want to increase bird index plus equal 1. However, this is going to get us into an error message really fast, because this number is going to get quite large really fast, but our list only goes until 2. So we have 0, 1, and 2. So if it gets greater than 2, then Python is going to throw us an error. So we have to make sure that this list never gets greater than 2. Which fortunately we can do really easily with an if statement. That if bird index is greater than 2, then we want to run this one, and else bird index is going to be 0. And basically what happens here is that at the start, bird index is going to be 0. So this one triggers, and the actual bird index is going to be 1. Then on the next frame, bird index is going to be 1, and when we add bird index plus 1, we get bird index is equal to 2. And then on the next frame, since bird index now is going to be 2, this one is not going to be triggering anymore. Instead, we get this line here, where bird index is going to be 0. And then the entire thing starts again. So this loop always goes 1, 2, 0, 1, 2, 0, and so on. And I could be running this now, but it would not be working, because we have to apply this bird index actually to this list when we come into our game loop. And we could be doing this in here as well. And what I want to do is bird surface and bird rect is going to get values from what I call bird animation. And all that this function does is that it takes an item from this list and it puts a new rectangle around it. And putting a new rectangle around it is kind of important, because these might have different dimensions. I actually didn't check. But the rectangle has to have the same dimensions as the surface it's surrounding. Otherwise, Pygame would throw us an error. So we have to do both. But this kind of function is actually quite easy. Let me create it down here. Def bird animation. I hope that was the same name. Yeah, there we go. So the first thing we want to do in here is to create a new surface that gets from bird frames, and we pick from bird index. So this one actually updates our bird. And then I also need a new bird rect. And this one is just as before, new bird.get rect. And the center is going to get slightly more complex. So the export of this is quite easy. It is always going to be 100. So the center of our bird is always going to be 100 pixels from the left. However, the Y part can change quite a bit, because this one has to be where our previous bird was. And this one we can actually get. We need bird rect.center Y. So what effectively happens here is when we are creating this new rectangle, we take the center Y of the previous bird rectangle, so that we don't change the position of the bird when we are updating our bird. But that is all we need. Now we can just return both. So it's new bird and new bird rect. And now let's try this. So now we can see a bird with flapping wings, and everything else still works fine. And yeah, there we go. It's really starting to come together. I'm still terrible at this game though. But alright. And with that one done, we've actually finished all the really difficult parts. Now we just need to add score and the game over screen, and we are pretty much done. So let's start with the score. And I want two kinds of scores. The score for our current game and a high score. And then whenever the current score is greater than our high score, we want to update the high score. And the first thing I'm going to need for that is two new variables that I call score, which starts at 0, and high score, which is also starting at 0. But we have to put both of these on our screen. And for that, we have to understand how Pygame handles text. And it's not too complicated, but there are a couple of steps towards that. So let's go through them one by one. The first thing you need for text in pygame is to create a new font. And this font has a style and a size, so what the font looks like and how large the font is. And all of this goes into the first big step. The second step then is to use this font and render it. And what that means is that you are actually writing something with that text. And in this step, you also give your text a color. And whenever you write text in pygame, you're putting this on a new surface. So once you have rendered text, you have a new surface with some text on it. And from here you can put a rectangle around the surface and put it somewhere on the screen, just like we have done before. And let's follow through on these steps and create our score. And the first thing we need is to create a font. And I'm going to do this right at the top in our code below init. And I'm going to call this game font. And to create a font, we need pygame.font.font. And make sure this one has an uppercase F. And now we need two pieces of information. We need the size of the text and the font we want to use. The text size is the easier part. Let's just go with 40, which is a fairly large font size. But now we need the font style. And font styles are stored in a very specific kind of format. It's called TTF. And Flappy Bird has a font that's called 04B_19. I have no idea who gave the name. But you can find the font in the game folder, and it has to be in the same game folder. But what I want to do is import that font.ttf. So now we have a font with this style and this size. Now we need to use that font to write some text on the screen. So I'm going to create a function that I'm going to call score display. And for now, this one is only going to show the score for our main game. We don't worry about the high score just yet. And in here, we first have to render our text, which is going to be stored on a new surface. So we first need a variable that I'm going to call score surface. And we need gamefont.render. And in here, we need three pieces of information. The first one is the actual text we want to render. And for now, let's just go with test. Actually, let's go with score. Then we need to tell pygame if this text is going to be anti-aliased or not. And anti-aliased text just looks a bit sharper. So I'm going to go with true. But this could also be false, it doesn't make too much of an impact. And now we need the color of our screen. And in my case, I'm going to go with 255, 255, and 255. So what does that mean? Well, this is an RGB tuple, and RGB stands for red, green, and blue. So this is the amount of red we have, this is the amount of green we have, and this is the amount of blue we have. And for each of them, we can choose between 0 and 255. And then pygame is going to mix these three colors together and give us an output color. And if you max out all the three different colors, you're going to get white. If you go with 0 for all three colors, you're going to get black. And if you only went with something like 255, 0, and 0, then you get red. Because you only have the red color, you have nothing of the two other colors. And that's basically RGB. It's just three different colors and you mix their intensity together. So now we have a new score surface. Next step is to put this surface on the screen. And to do that, I'm going to put a rectangle around it, just to make it easier to put it in the middle of the screen. So I'm going to call this score rect. And this is going to be score surface.get rect. And let me fix the typo. And center is going to be 288, so half of our X space. And then I'm going to put this roughly at the top of the screen, which is going to be 100. So 100 pixels from the top of the screen. And now I just need screen.lit score surface and score rect. And this is all we need to put some text on the screen. So now we have to call score display, and let's put it at the end of our game active screen. So I called it score display, and this should be working. So now we have score at the top of the screen. Doesn't do anything yet, but that's going to come in a second. Let's work on it now actually. So right now we are only drawing score, and I don't want that. Instead, I want to print our score, this one here. So I want score in here. But this one pygame would not like, because this render needs a string, and this one is an integer. So we have to change this to a string. Very easily done. And if I run this now, we can see 0 because we're not updating the score. But that we can do right now. So in our game loop, here I am drawing our score. And I just want to update the score plus equal 1. And this is going to get a bit crazy. Let me show. So now our score increases way too fast, which isn't good. And instead I just want to increase it by 0.01. But if I run the code now, we're getting a float, which is going to have a very silly outcome. Let me show. And this is why floats are a bit weird. They produce really long numbers. So we have to convert this new number into an integer first and then into a string, which fortunately we can do very easily. And I have my score up here. So this score right now is going to be a float. And I want this to be an integer. And this is going to fix the entire thing. And now we have 1, 2, 3, and so on. So this one is working quite nicely. So now I have a score, but I also want to display a high score. But I only want to display this high score if we're on the game over screen. So I have to change this function a tiny bit to accommodate for that. What I'm going to do is I'm going to give this a parameter that is going to get a string later on. And this string could either be game or game over. And if it's game over, it's going to display a high score. If it's game, it is only going to display the score. So if game state is equal to, let's call it main game, then we're doing this. And let's do another if game state is equal to game over. Then we are still going to draw our current score, but we are also going to draw a high score. And for that, I can just copy the entire thing because we're still just working with text and just add high score in front of everything. So this is gonna be high score rect, high score rect, high score, and high score surface, and high score rect. And yeah, this looks good. And then in our game loop, that is going to be down here. Then when we call score display, this one's gonna get game. Called it main game, I think. Main game. Yeah, this one, main game. There we go. So now we are showing the score in our main game. But I also want an else statement that if our game is over, I still want to display the score. So now we have score display. And this is going to be game over. So now if our main game is active, we are only going to show our current score. However, if that is not the case, so if the game is over, then we're going to run this function in a slightly different way. And before running this, there's one thing I just realized that I forgot. And let me go all the way up again to our score display function. And right now we put in this line here, we put our score surface and our high score surface on the same position, which wouldn't be good. So I have to change the Y position for the high score. And by trial and error, I found 850 works best. So let's try it now and let's see how this looks. So this one works fine. If I run against something, we have 2 at the top, this is our score, and we have 0 at the bottom, which is our high score, or it's going to be our high score in just a bit. And I think in our game over screen, we don't just want to display the number, we want to put text next to it, which we can do with f strings. So let me get rid of this part here and create an f string. And what I want in here is score, and then curly brackets, and pass in our score in there. And then I can copy the entire thing and change this one to high score. And this one should also be high score. And f strings basically combine a normal string with any other kind of variable that we can pass into curly brackets. Quite useful. So let me try this again. And this one seems working. If I die now, we have a score at the top and a high score at the bottom. But our high score doesn't update, so let's work on that. And this I'm going to put into a new function that I call define update score. And update score doesn't need to do anything complicated. All it needs to check is if our score is greater than our high score. And if that is the case, then our high score is going to be our score. So if the score is ever greater than high score, then the high score is going to get the value of the score. And since this high score right now is in the local scope of this function, we have to return it. So return high score. And I actually have to pass in score and high score as parameters to make this work properly. And now this should be working. So let's go to our game loop down here in the else. And before we are calling the score display, we want to update our high score. So high score is going to get update score. And we want to pass in score and high score. So let's try this now. And if I crash against something, now we have our score is 2 and our high score is 2 as well. So now let me try to go higher. Ah, yeah, right, we don't reset the score. So now if I play again, score is going to be 4 and high score is also going to be 4. And there's one bug right now that if I start again, we don't reset the score, so it's always increasing, which doesn't help too much. So let's work on that actually. And that is super easy to fix because just as before, when we are calling, I think it was in here. Yeah, so if we call key space and game active is false, so restarting the game, then we also want score to be 0, because otherwise the score is always increasing. So now let's try this again. So we go 0, 1, and we die. Now we have 2. Now it starts at 0 again, and let me try not to die. And now we have score 3, and high score also updates, because our new score was higher than the previous high score. And if I try this again, and we get to 5, now we have 5 as the high score. So the high score is working. We are making a ton of progress. Now for the final part, all we have left to do, and that is going to be to make the game over screen look a bit better and to add some sound effects to it. And then we are done with the entire game. So let's start by making the game over screen look a bit prettier. And I'm going to make this quite easy. All we really need to do is to take an image and put it in the middle of the game over screen. And you're going to see in a second what that means specifically. So here we are back in our code, and all the way at the bottom of all of our game variables, I'm going to create a new variable that is going to go game over surface. And for this one, it's just an image, pygame.image.load. And this one is also in the assets folder, and it is called message.png. And as always, I want to convert it, and I also want to scale it up. And by now, I guess we can just put all of this into one line to save us some writing space. And now we just want to put this in the middle of the screen. And to do that, we need a rectangle. So let's call it game over rect is game over surface.get rect. And the center is going to be 288 and 512. So the exact center of our screen. And now when the game is over, we want to display that, which I'm going to do in the else statement. And it's just going to be screen.blit game over surface and game over rect. And let's see if this is working. And let me just destroy myself. And now we can see that we should have used the alpha value, because right now anything that's supposed to be empty is going to be black. So let's try this again with convert alpha. And let me die again. Now this looks much better. So now we see a message, and if we press space again, this one is working again. And we can also get our high score. And here we go. This all works much better now. So, making good progress. Now the last thing is to add some sound effects to this. And that actually brings us to a new topic in Pygame, and that is to importing sounds. And for that we are going to need the mixer. And the mixer can be a bit of a tricky thing to work with. But let's go through it step by step. I think this is going to work best in code. The first thing I want to do is to import a sound that when we press our space button, our bird is making a flap. So I'm going to call the new variable flap sound. And to import a sound file, we need pygame.mixer.sound. And now we need a file location, which in my case is sound/sfx_wing.wav. So this is a sound file. And we want to play this sound file whenever we are jumping or flapping our wing. And this is, let me open it, this case here. So all we have to do is flapsound.play. And this should be working. Let's actually try this. So I execute the code. And we can hear sound. But you probably noticed that this sound is massively delayed. And that is for a reason. And the reason is that Pygame tries to account for older computers that are really slow. So it first buffers the sound and then plays it once it's ready to play the sound in high quality. But this takes quite a bit. And as a consequence, the sound only plays a few milliseconds after we have done the action, which is really confusing. So let's fix that one. And to fix this one, we have to pre-init our mixer. So remember about 1 billion years ago, we initiated Pygame? Well, this one also initiated mixer, and we can customize this initiation for mixer. And what we need is pygame.mixer.pre-init. And what pre-init does is it tells this initiation method to initiate mixer in a certain way. And now we have to give it some arguments to initiate it in a specific way. And here we have a couple of arguments we need. The first one is the frequency. And by default, this one is 44,100. And we're going to leave it at that. Then the second one is the size of the file. And this one is 16, also by default. Then we have channels. And by default, this one is 2. But I only want this to be 1. And then we have a buffer. That is really important for quality. And I'm going to put this at 256. And this is all we need. And I think it's going to be a bit of an overkill to explain all of these in detail. And Pygame explains this on the website in quite a bit more detail. Check this one out if you really care. But if I run the code now, this should be working much better. And maybe you can hear it, but the sound quality went quite terrible. And this is because this buffer size got too small. So let's switch it back to 512. And this works much better. So now the sound plays immediately and it sounds kind of alright. So we have our basic sound. So now we need 2 more sounds. The first sound when we hit a pipe, the second sound is when the score updates. And to do that, we first need to import a couple more sounds. The first one I called def sound. And this one is pygame.mixer.sound. And we need sound and sfx_hit.wav. And then finally I have score sound, and that is pygame.mixer.sound. It is also in the sound folder, and this one is called sfx_point.wav. So this is the sound when we hit the pipe, this is the sound when we update the score. Let's start with the def sound. So if we hit a pipe, and this one, we just have to get to our check collision function. And if this one is true, then we want to play the sound. So quite an easy thing to do. So def sound.play. And if I try this, we're getting an error message that score sound is not defined. Because I made a typo. Try it now. And we can hear a sound when we hit a pipe. And we still go to our game over screen, all of this is working. So for the final thing, we want to play a sound when our score updates. We're just going to get slightly more complicated. And let me minimize the event loop. So what we want is if this score gets to a full number, then we want to play a sound. But this is kind of difficult to measure. So instead what I have done, I have created a new variable that I called score sound countdown. and this one starts at 100. And then in our game loop, I reduce this one by 1 score sound countdown. I'm going to reduce this by 1 on every cycle of the loop. And if it is 0, so if score sound countdown is equal to 0, or as I said before, smaller or equal than 0, just to be sure, then we want to play the sound. So score sound.play. And then we want to set score sound countdown back to 100. So effectively this one is 1/100th of 1, and this one is 100. And we are changing them at the same speed. So this one needs 100 cycles to get to 1, and this one needs 100 cycles to get to 0. So they basically trigger at the same time. And that's all we need. Let's try this now. And we hear sound when we get a score. And yeah, that is actually working. And with that, I think we have our entire game. I hope you enjoyed this tutorial, and I'll see you around.